All right, so welcome everyone. Thank you so much for joining us today. This is one of my favorite presentations at Origin and Cause. I was just telling Eduardo and Mark, who helps with our marketing. This is such a great presentation. I've attended it multiple times and it's still, I always learn something new. So really excited for you to join us today in fire sprinkler systems, understanding how and why they fail. I just wanted to go through a few quick points with you first. We'll be doing a Q&A period at the end of the webinar. So please feel free to submit your questions in the text box under the webinar screen there in your GoToWebinar portal. We'll be trying to get to as many questions as possible in this hour. If we don't get to your question in the webinar, we promise to follow up with you after and make sure that your questions are answered. All questions are going to be anonymously addressed, and the webinar is being recorded and is going to be posted on our website, LinkedIn, YouTube pages, so please feel free to pass them on to your colleagues or use them in your team meetings if you wish. We'll be issuing completion certificates for those that have not attended this in the past and have not used the credits in the past. Actually, we will be sending completion certificates to everyone, but this is a webinar that's been redone in the past year. So if you actually have used the credits already, then this would just be a review for you. At the end of the webinar, when you close the GoToWebinar window, the program is going to prompt you to answer a few questions about the webinar, but it's just an opportunity for you to provide us with feedback about the speaker, the content, and provide other feedback if you wish. If you're experiencing any sort of technical difficulties, just reach out to my team at webinar@origin-and-cause.com. All right, let's get started. So just want to introduce to you our speaker, Eduardo Mari. He has a master's degree in materials science and engineering, has completed over 20 years of field experience, and has led over 900 forensic investigations. He is a member of the National Association of Corrosion Engineers, as well as a board member of the Canadian Standards Association B139. So I'll pass on the mic to Eduardo, and I hope everyone enjoys.
Thank you, George, and thank you everyone for joining today. Very happy to present this content to you. Speaking about sprinkler systems, the first thing that comes to mind and we should address is how effective they are. And in reality, they are very reliable, very effective at reducing property damage when they are installed in the building and functioning properly. And as well as civilian deaths from fires can be reduced up to 90% when sprinkler systems are installed in a building. Now, that is when everything is working properly, and we get involved when things don't go exactly according to plan, whether they are not properly manufactured, designed, installed, used, and maintained. And then we get called in to inspect and provide an opinion as to why things went wrong. One of the things important in sprinkler systems is that they are highly regulated. There are a number of standards like the NFPA 13, which is the one that deals with the installation of the systems, as well as the NFPA 25, which deals with the inspection, testing, and maintenance of these systems. And again, these standards are important because they do provide that framework to complete, on one side, the installation and the maintenance, and on the other side, for me, when I go and investigate, for me to complete that investigation and make sure that everything was according to the initial specs or the requirements over the years. And whenever I do an investigation, I refer to the standards every single time, especially when a failure appears to be related to a maintenance issue. And remember, when you send a claim my way for an opinion, the standards are always part of the equation. And I will always provide you with some feedback as to whether the system was compliant or non-compliant, and the appropriate approach to your claim or to your subrogation file. So there's a number of different types of sprinkler systems, and before we go very deep into this topic, I'd like to cover some basic principles in terms of sprinkler systems, so we get everyone on the same page. First, I'd like to discuss the main two types of sprinkler systems, which are wet pipe and dry pipe. Each one of these has its own advantages and disadvantages. You will typically see a wet sprinkler system in your office space, in warehouses, in apartment units, and the dry systems are normally installed in exposed locations, such as parking garages, outdoor patios, and balconies. So basically, if it is exposed to the cold elements here in the northern or in these areas where we experience cold climate in the wintertime, then that's where you'll see a dry sprinkler system. Just going over what a wet pipe sprinkler system is, very quickly, if you see the graph here, the entire system is filled with water. It's a lot less complex than the dry systems, less expensive as well to install compared to a dry system, and it's very easy to install and maintain. It is used typically in about, you could say, 90% of all sprinkler installations. And again, one of the main advantages is that it's simple, reliable, effective. When it comes to a dry sprinkler system, these are, if you see the graph here, these are filled with air. The water comes from the city or from the pumps, and then there's a valve that holds off that water. And then the air, because it will not freeze, can be, so all that piping can be exposed to low temperatures. It is, again, more expensive to install. It is more difficult to maintain because of a number of reasons. And it has a slightly slower response time. When I say response time, it means there is a delay between the moment when the sprinkler head activates and the water actually starts taking care of that situation there. As I mentioned before, these systems can be used in very commonly parking garages and outdoor spaces. And the way it works is once the sprinkler head detects the fire, it bursts, and then air starts to escape. The pressure, that air pressure in the system starts to drop, and then at some point, the valve opens, allowing water to come in and extinguish the fire. I usually receive claims related to dry systems during the wintertime, when freezing occurs in the pipes that were either not properly drained, not properly maintained, or not inspected properly. I have two good examples that I dealt with on dry sprinkler system claims. One of them was where a contractor in a building completed some repairs to that dry sprinkler system, but there are multiple lines, multiple pipes, and they forgot to drain one of them. And this resulted in the bursting of the pipes and a flood in that building. The second one was similar in a retirement home. And the attic the attic in newer constructions need to be sprinklered. The attic is a dry sprinkler system, and because there is condensation in the system, and there are some areas because the way the attic is constructed, there may be some areas of the piping that have to go lower than the rest, and then at those points you have to install a low point drain. So again, the contractor forgot to drain that low point, causing it to fail, and significant damage was caused to that facility there. It's in both of these cases, the important thing during my investigation, during my inspection, was obviously inspecting the site. It's very critical that we go on site and do an inspection there. It is very important that we review the drawings and all the records for maintenance and inspections. And based on all of that, we can, I would say almost all the times, provide a definitive opinion as to what caused that failure. And in these two cases I presented, my clients were very successful in their subrogation efforts. Okay, so what is the anatomy of sprinkler systems? Well, there are two key pieces that I would like to cover. One is the piping and the different materials that are used today, and two is or the sprinkler heads. By no means this is an exhaustive list of sprinkler system components, but rather just an overview of those most likely to fail or to sustain damage that can lead to water losses. These are obviously very robust systems, as I mentioned before, but for the purposes of this webinar, I'm just going to cover the basics and hope to do a second webinar later on more advanced details for you all. Again, the pipe materials used. We are very familiar with these two, I'm sure, steel pipe and CPVC pipe, or chlorinated polyvinyl chloride pipe. Each of these two pipe materials have their positives and their negatives that should be aware, or that you should be aware for your claims. When it comes to steel pipe, it has traditionally been the material of choice for fire sprinkler pipes because of a number of things, including its strength, its durability, and its high resistance to heat. So when there's a fire, the steel pipe can resist the heat being produced a little bit or better than the plastic pipe can. Again, like we're saying, the high melting point of the steel means that even when it's subject to very intense heat from the fire, it will maintain the flow of water to it. The plastic pipe, the CPVC plastic pipe used today has some very good characteristics as well. But again, steel pipe is just I would say the material of choice traditionally. Of course, there are some negatives as well. One, that is heavy. Two, it is less flexible when compared to plastic piping, and that can provide some installation challenges. Or if you see the other way, installing plastic pipe is easier than installing steel pipe. And it's also susceptible to corrosion. As you can see here in the picture, this is a lot of corrosion deposits inside a steel pipe. And those deposits, either corrosion or bacterial growth, can lead to clogging of some of the pipes, and that's why some of the maintenance includes inspection for that. So that is also covered in the maintenance part. When it comes to CPVC pipe, again, what are the positives? Very clear: inexpensive, it's lightweight, it's easy to install, and it's resistant to corrosion. So those provide some very clear differences between plastic pipe and steel pipe. And for those of you who didn't know, the CPVC pipes have been used since the 1980s. So we have a lot of experience with them. There's been quite some interesting changes over the years. And again, currently, it is becoming the most popular material of choice because in greater part because of the cost, right? It is much less expensive than steel pipe. What are the negatives? Well, obviously, the melting or softening point is around 100 Celsius. again, don't be too concerned about this. The CPVC, even though it starts to soften, it still functions while exposed to heat. It just starts to char, and it will last less time in a very intense heat as compared to steel, but it will perform. It is susceptible to damage from UV exposure. So if you leave it outside in the sun, it's going to degrade and produce some damage to it. Obviously, if you step on it, you impact it, it's going to crack, and that's never good. In some of in Canada, it is limited to light hazard occupancies, so low and high-rise residentials, as well as family dwellings and manufactured homes, as opposed to steel piping that can be used in industrial applications. One important failure mechanism is that it is subject to environmental stress cracking, which is a failure mode that it's very hard to detect in its early stages, and we find it when it's too late and it starts leaking. Okay, let's move on to the second component of interest today, which is the sprinkler heads. In most systems, each sprinkler head activates independently of each other, and it is triggered only when the temperature reaches a specific level, which helps minimize water damage from the discharge from that sprinkler head. What you see in some movies that when one sprinkler head is activated and all of them go off, that is just something that's not very accurate. There are some sprinkler systems that do that. However, not all of them activate like that. Sorry. In any case, the important thing to keep in mind is that the way they work is that they concentrate the water pressure over the area of origin. So if you have a fire confined to, say, the kitchen area, then only that sprinkler head is going to activate, unless once it's activated, it is not able to contain the fire, and then subsequent sprinkler heads will activate until the fire is contained or suppressed, either by the system or by the fire department. So main parts of a sprinkler head, they are usually brass material, and they have either a heat-sensitive glass bulb, or in some cases a soldered fusible link. And what it does is it holds a cap in place. Once that glass bulb bursts because of the temperature, then water starts to flow. And you can see many of these in residential applications or small commercial installations. In my own experience, I would say that the activation of these heads without a fire or a heat source can be a little bit of a challenge when it comes to finding the root cause of the activation. If you see the parts of the sprinkler head, once that glass bulb is shattered, there's not much left for me to investigate it. So there are a number of cases when some of these sprinkler heads can activate inadvertently or accidentally by either a defect on the glass bulb, or because they've been exposed to heat over a long period of time in the case of the fusible links. But those are very, very rare. It's about 1 in 16 million cases. And most of the times, the activation of the head is a result of something that happened. So either there was heat or there was some interaction from the occupants of that building. This is what I was explaining before, that some of the sprinkler heads can have a fusible link. So no glass, it's just two pieces of metal that are joined by solder. And once it reaches a temperature, it goes off. These heads are typically more robust, and you can find them in high-rise residential or industrial applications. They're not as susceptible to being damaged. And if all the pieces are found during my investigation or the cleanup process and saved, then they do provide a much better insight as to what the root cause of the failure was. So to this point, we just went through the two types of sprinkler systems, so wet and dry, as well as the anatomy of the system, such as the pipes and the sprinkler heads. Now, what I'd like to do is go through the common causes of failures in these sprinkler systems. So for one is occupant damages. So if the occupant damages the system. Two, improper installations. We can also have lack or improper maintenance, and obviously the manufacturing defects. Occupant damages. I recall a nice case in a downtown hotel when where the one of the guests, so the fire alarm activated, water started spilling out of the wall-mounted sprinkler head, and the guest ran out to the hall and said he was so sorry to have put a cloth hanger on one of the the sprinkler heads. Yeah, it's very common, and what the industry has been doing in the last few years is changing some of those exposed sprinkler heads to concealed sprinkler heads. So what is happening now is you will not see the sprinkler head. It is more resilient. It is protected from damage from the occupant of the unit or the building, and they are the same. They have the same effectiveness, of course. So in my experience, this used to happen a lot in hotels with those exposed heads, and when it comes to my investigation, it is very important that we obtain the statements from all the parties involved, so the security personnel, the witnesses, the occupants as well, and the first responders, like a fire department, for instance. Other types of damages include accidental impacts, such as with forklifts, ladders, and sports equipment. So in an arena, you can have sprinkler heads, and if they're hit with a baseball or something, then obviously they can be damaged and go off. Again, these are examples of my investigations where an occupant damaged the sprinkler head. In this case, the occupant put some putty or some drywall compound in the head, the concealed head. This was very interesting because it wasn't only one head, it was all the heads in that apartment unit. And there were obviously some big issues raised in that case. Again, as I was saying, in other cases, when you have the fusible link, it's important to collect all the parts. In this case, we have most of the parts, and then we can look very closely at those features in the fusible link and determine whether there was some heat applied, like with a torch or something like a hair dryer or something like that, or simply it was a manufacturing defect or some material issue which caused it to creep. And then we can differentiate whether the failure was due to manufacturing issue or as a result of a damage by the occupant or intentionally damaged. When it comes to improper installation, in my experience, it's the second most common cause of failure. And when it comes to plastic pipe, the CPVC is obviously easier to install because it uses solvent cement instead of threaded connections, but improperly joined sections can separate from each other and cause significant damages. So I have a case study which I'm going to show, and in which the joint was improperly made and it's separated. In this case, you can see here in the with the red arrow, basically that's where the pipe was. So the pipe is the one with the purple cement, and the red arrow is the depth of insertion of that pipe into the fitting that's separated. You can see the white arrow showing that the pipe was cut really poorly. It was, during the inspection, we found that it was not properly cut, not properly deburred, not properly chamfered. So a number of issues with that installation. And obviously, there was another issue here, which is that the pressure was on the high end of the specification. So even if they had done a better job at cutting the pipe, then it is still possible that they didn't wait long enough for the joint or the cement to cure, and that way, and in that way, just separated. So a number of things to consider when it comes to installation of CPVC systems, and why they separate. But again, going back to the basics is always important. So documenting, interviewing, and securing the evidence. One other thing that occurs with when pipes are improperly installed, or CPVC pipes are improperly installed, is something called environmental stress cracking, or ESC. ESC is caused by exposure to some components like oils, solvents, or antimicrobial coatings in some of the piping. And the installer should or must know how to prevent the pipe from becoming or coming into contact with these solvents or oils to prevent ESC. Like I was saying, some coatings in the steel pipe that are in the building as well may cause some issues. Some electrical wiring that may come in contact with the CPVC pipe can also cause an issue. So if we suspect that the electricians used wires and left them in contact with the pipes, we also have to investigate that. And again, ESC originates at a molecular level and atomic molecular level, and basically we cannot see it, and we cannot detect it until usually it's too late. In this case, you can see in the picture on the left the result of a severe environmental stress cracking of that pipe. You can see the multiple cracks on the pipe. On the right, it's a very typical way of this ESC crack progress and propagate through the thickness of that pipe. So as you can see, there are some progression lines. What that indicates to me when I investigate is that obviously this is not a new issue. This is not something that happened instantaneously. It's something that's been going on for some time. And it also gives me an area of origin, and I can use some analytical techniques to identify some of the components that can be left over there and determine why it initiated. So when it comes to sprinkler heads, when they're improperly installed, they can be, for instance, installed with a temperature rating that is not appropriate for that application. So if you install a sprinkler head that's supposed to be for a bedroom in a commercial kitchen, so in a restaurant, then it's possible that it's going to activate because the heat from the kitchen is rising to the ceiling level and it's going to accumulate there and possibly activate that. Matter of fact, I've had a number of cases like that when they do in those 3 or 4 cases, all of them had some changes to the occupancy. So they had a small kitchen before in that commercial space, and they made a bigger kitchen. Obviously, they've done all the work, all the inspections, all the permits, but along the way, someone forgot to change the sprinkler head, and they left the lower temperature rating heads, which activated with the heat. And again, whenever you see the sprinkler heads in your office or in your building, they have color coding. If you see orange or red, those are typically for commercial or residential applications, and then they change as they go higher temperature. Now, the wrong head in the wrong place. Again, as I was saying, when you repurpose a space, you always have to rerun the calculations and rerun the occupancy calculations, occupancy drawings, the size of the sprinkler head, the size of the sprinkler system, location of the heads, and reinstall the appropriate heads. In a case like this, look at this space here. It's a warehouse. It had a change of occupancy. It went from a warehouse that didn't have such a large fire load. So obviously, if you look at this, these are carpets, and there's a lot of them all the way to the ceiling. They had an issue with the system here, and obviously it got more complicated than just a couple heads going off. In this particular case, it was some attempted fraud, but they were trying to. The way I saw it, or in my opinion, they were trying to hide it behind some of the work that was done by the contractor, and in any case, in the end, we were able to prove that it wasn't possible for so many heads to go off simultaneously, and it was not a contractor's fault, but someone who tried to make it look like something else. Again, when it comes to maintenance, these systems are very reliable, but they do need maintenance. And it's good that the NFPA 25 guides and controls what kind of maintenance has to be done and must be done on the system. So the freezing, for instance, in a parking garage is something that shouldn't happen because those pipes should be filled with air. And yes, these are very interesting to investigate. And when it comes to the installation to begin with, and we look at NFPA 13, they do not permit the use of wet pipes unless the temperature can be constantly maintained above 4 Celsius. So if you look at a parking garage, most likely it's not going to be guaranteed that it can be maintained above 4 Celsius. However, in some cases, they try to push it a little bit, and well, you can see the result in this case. So again, when it comes to freezing, we have to look not only at the installation, not only at the maintenance, but also whether there was appropriate heating provided to that system. So if a wet system is adequately installed, properly maintained, but it still freezes, it can all lead to some issue with the heat in the building. So sometimes we tend to jump to conclusions, say, oh, it froze, must have been improperly maintained or improperly installed. But let's not forget that in some cases, the heat to the building is not necessarily a guarantee. Like this is a very typical failure on a steel pipe or a steel fitting. When it freezes, it splits. And you can see on the picture on the right, that's where it came from. And you can see that the insulation there was not pretty good. Actually, it's not approved insulation. Whoever was the contractor there did a really bad job. And obviously, my job was to point that out. And that was actually a very, very easy subrogation case for my client. That's the foam they used. Again, improper installation can also mean some of the mechanical fittings not being properly tightened and they just become loose. This is a 6-inch pipe, and you can imagine the amount of water that came out of that. It was so much water and so much pressure that it actually destroyed a cinder block wall in that building. And this was right in the lobby when that cinder block wall exploded, as it was described by the property manager. Everyone thought it was something else. So luckily nobody got hurt, but significantly damaged because of improper installation. Now, when we go back to lack or improper maintenance, this is something that I see very commonly on the field. And again, it's either lack of inspections, improper inspections, and whenever you, as an adjuster, find something like this, always leave the damaged components untouched. Leave them on site. Try to find someone who can do the investigation for you, so we can properly document it. I know there's pressure. I know there's a lot of pressure to get the systems back up and running because of the fire watch conditions that can be called in if not, or because you need to provide protection to the system or to the rest of the building. So I know all of that, but still, if you can't find someone in time, at least try to document the system properly. And when it comes to failures resulting resulting from a slow leak that can go unnoticed, that is, it's a little bit more of a involved investigation because trying to find out when that leak started can be a little difficult, but it's not impossible. There's also an issue of a failure to perform. So if a system is rated to cover a specific area in that building, and there is a reduced flow due to a number of things, either a blockage in the pipe or something else, like valves not properly open or valves not properly functioning, then obviously all of that goes back to maintenance, and we can trace that back and find out who was supposed to be doing that. And a very typical issue is the heads get painted. When a head gets painted, it reduces its activation time. Sorry, increases its activation time, so reduces its performance. And you can have a fire that spreads beyond what it should have, and then we can look at that as well and determine whether someone should have been inspecting those heads and find the issue beforehand and prevent the additional damages that result from that. When it comes to corrosion, corrosion happens in both wet and dry systems. However, dry systems are more susceptible because they have a chamber full of air and some water, residual water, and those are the preferred conditions for corrosion to happen. So you have a lot of oxygen, some water, corrosion happens. When you see it the other way, if you see a full pipe, then over time that level of oxygen is going to reduce, and therefore corrosion is going to reduce as well over time. If corrosion is not inspected, detected, and properly dealt with, it can lead to failures and obviously damages from it. When it comes to what is required, the NFPA 25 clearly identifies what needs to be done. So there is no back and forth as to what the contractor had to do. It is all very clearly specified, and if not done, then we see the results. Again, as I was saying before, when you receive a sprinkler system claim, try to pay attention to the building codes and the standards that were applicable when the system was installed or when the building was built. It's sometimes, or not sometimes, the codes do change, the standards have changed, and a system that looks today as if it wasn't properly installed may not be the case. It may have been installed at the time when it was approved, and it's still allowed to be working today. There are some exceptions, of course, but for the most part, we had to review in a little detail just to find out if it was still appropriate for the operation. It's important to ask for the inspection and the maintenance records, and it's important to document the scene thoroughly and quickly. As I mentioned before, the repairs on a sprinkler system usually happen immediately. It means the same day or the day after. So if you get a case like that, don't wait until the next day to take your photos or to visit the site or to contact an expert. Again, what I find best in claims like this is to start the process early. It is a long process, especially when it involves getting information from third parties or the fire department. It can take a couple weeks or more for a fire department to send their reports, and they typically never share their photos. So if you can find photos from witnesses, those are great. A few other quick tips on subrogation and legal files when it comes to sprinkler system claims. Again, the standards include details relating to the installation, to the inspection and maintenance of the systems. But think outside the box, right? A failure in one point of the system may have its root cause somewhere else. So don't only focus on the area where it failed. For example, or a freezing failure is not necessarily that it was freezing outside, but something was wrong in the installation or maintenance. So yes, it froze. Yes, it was cold, but was someone supposed to take care of that watering the system beforehand? I've also noticed that in some cases where large or complex losses occur, a fire watch is established and the repairs are not completed immediately because sometimes the equipment needs to be sourced. And in these cases, that gives an excellent opportunity to visit the site or to arrange for your expert to attend. Also, if you cannot attend the same day. If your expert cannot attend the same day, you can always try and think if a fire watch is appropriate, and you can discuss that with the property manager or the fire department as well, and then you give time for yourself and for your expert to attend the site. As a concluding note for sprinkler systems, manufacturer defects are quite rare in these systems, but they do happen from time to time. So there isn't an overwhelming trend on what fails so that we can attack them as a trend, but we just deal with them on a case-by-case basis. So if we suspect a manufacturing issue, we will let you know and we will deal with it as it comes. At this point, that was all from my presentation. I will pass it to George to see what your questions are and hopefully answer them.
Thank you, Eduardo. That was great. So folks, please submit your questions in the questions tab there in the GoToWebinar console. We have a few questions that have been submitted, and so we'll get started while others are submitting them. First question, I am in marine claims, and oftentimes we see high-end large boats are equipped with sprinkler systems. Are the standards the same, or are the standards that you're referring to only for buildings? So I believe that was when you were talking about the ASTM standards.
Yeah, so the NFPA standards that I deal with here are for buildings, but that doesn't mean there's no particular standards for marine applications. The piping will be different. The sprinkler heads themselves may be similar, and again, the failure modes are similar as well. So even though the standards for installation and maintenance may differ, the failure modes are similar. And if you have a particular question that you would like me to review, I'll be more than happy to assist you with that.
Yes, that is a really great question, and we do encounter quite a bit of claims investigations relating to marine claims, obviously, and sprinkler systems are often involved in such investigations. Next question, can you talk further about the magnitude costs per linear foot or building area for sprinkler system piping replacement based on pipe diameter and steel versus CPVC?
No, I don't have information on cost, but remember, whenever you change piping, or whenever you think of replacing a system, it's not only the piping that's involved, it's all of the upstream as well. So the pumping, the valves, everything that is involved in that system. So not necessarily just the piping.
Yes. They're also asking specifically about cost replacement of sprinkler heads, wet versus dry systems. Again, costing is something that you would not be involved in, Eduardo?
No, costing is not, but the sprinkler heads don't change much, or there's not necessarily a change because you use a wet or a dry system. If you're using regular, let me just say it in a different way. There are some heads that can be used in wet and dry systems. So because the way they activate is the same. However, there are some sprinkler heads specifically designed for dry systems, and there are some sprinkler heads which are designed for use in a wet system that connects to an outdoor space or to a uncontrolled space, so say a freezer or a balcony. So you don't necessarily need to have a dry system. You can use the same wet system and then have a special head that is designed to withstand the cold environment and still do provide protection.
Great. What color code are sprinkler heads intended for residential spaces, i.e. you said orange and red are for commercial. Are they the same for residential spaces?
Yeah, so residential is orange or red, same as small commercial. But it depends, right? When you have a commercial space, you can have a store that sells clothes, or you can have a restaurant, and then the restaurant in the dining area can have the regular low temperature red bulbs, but in the kitchen area they have to be higher temperature, so green or blue. And it's not only the temperature rating. It's much more complex than that, because it's how much flow can go through the head, what type of droplets are produced, what coverage area you get. So that's why that has to be designed or properly designed by an expert, an engineer. And whenever there's a change of occupancy, it has to be completely reviewed and redesigned.
Cool. Great. Next question. Can you insulate around the pipe in a wet system to better the chance of not freezing?
Yes and no. So if we look at one classic example, so when you have a sprinkler system coming from the ceiling, and above the ceiling you have an attic space, what is allowed is that you lay down the sprinkler piping above the ceiling, so it can even be above the joists. But then you have to cover those pipes with a insulation. And there are different ways in which you can do it. The typical way is what they call the tippy. So you use bad insulation and lay it on top of the pipes, so that it traps the heat from the room going up, and it maintains the pipes warm. But if you wrap the pipe and leave the head exposed, then it is still going to freeze. So there has to be a proper way, and not only proper, it has to be an approved way. So you cannot come up with some way to do it. You have to follow what the standard requires.
Great. Next question. In some claims, the technician is unable to get to the shutoff of the main water valve. It's not really a question, it's more of a statement. Do you encounter such scenarios, Eduardo, often in your claims investigations?
Yes, all the time. And one good example to answer this question is there was a loss in a residential building. I can remember 20th floor or something. Water went all the way to the lobby. I can't remember if it was a relatively new building. Yes, sorry, it was a relatively new building, and the property management, the security people, they were not properly trained, and they could not find the shut-off valves for about an hour and a half. So something that could have been tackled early on went on for an extended period of time. They had to shut off the water to the entire building. And obviously, because the building has a lot more water, then that has to come out somewhere, and that somewhere was that valve or that sprinkler head. So in that particular case, I believe my client went after the property management and the security as well.
Yeah. Very cool. Very interesting. I'm seeing a couple of other people commenting saying, hey, I've seen that on one of my files before. So next is a sprinkler system considered a pressure vessel? What is the internal working pressure?
No, not a pressure vessel. A pressure vessel is different. A boiler may be considered a pressure vessel. The pressure in the sprinkler system can vary. So you can have say in the provinces or states where sprinkler systems are required in residential homes, the sprinkler pressure can be the one in your house. It can be 40 psi, it can be 100 psi, whatever you get from your city. In most sprinkler heads are rated for up to 175 psi. So what most systems do is they increase the pressure of the system to about 150 psi or 125 psi, and that way they don't get any variations from the city water. But again, a system that is at the point of the sprinkler head. The system in the branching and the main riser, it can have a higher pressure. Then it has to be reduced. When we have high-rise buildings, you have to make sure the water gets all the way from the basement all the way to the top. So you can have 300, 400 psi at the pump, and then you reduce the pressure accordingly.
Great. We have 4 minutes and a stack of questions. So let me go through rapid fire here, Eduardo, and we're going to test how quickly you could respond, okay?
Perfect. Yes.
What should be the heat rating for sprinkler heads located in high vaulted ceilings? I imagine that it depends on how high is high, right?
Yes, but again, the heat rises very quickly. So if you have a fire, the heat's going to rise really, really quickly. What may be more of a what may be more important here is the type of head. So if you have a head that is installed, that your typical 9-foot ceiling, then that's going to generate a droplet that is X number of millimeters in diameter. If the droplet is very small, right, then by the time that droplet comes down from a high ceiling, it's going to evaporate, and then no water is going to reach the fire. Then you need to get a sprinkler head that produces bigger droplets that will not evaporate in the fire and reach the actual fire source. So again, the rating, the temperature rating may not be the most important factor here, but the volume of water and the size of the droplet.
Great. What are the types of tests for dry systems?
So dry systems require testing that to ensure that there's no blockages, to ensure that the water can reach the farthest point of the system in under a number of seconds. Other test. Well, obviously that the system is properly drained before the onset of freezing temperatures in the winter time. So typically October is the month when all of the contractors are draining systems. A number of other testing during the winter time itself. So depending on the system, it may have more or less condensation, and it will fill some of those low points, and then they have to be drained. Some of those tasks are contracted out, but some of those tasks are kept in-house, so the property management people take care of it. But in some cases, nobody knows what's going on, and then they fail. And then obviously we get involved in, like I have a case I did about a year ago or so, where these residents had an issue where nobody knew. I mean, the property management didn't know about the system, and they didn't know to contract someone to look at it. By the time they contracted someone in December, then the system was already frozen. Whoever went to check the system couldn't see anything wrong, but obviously it was too late for them to see it, and then it failed in January.
Cool. Okay, probably the last question. Should low air alarms be installed on dry systems to avoid a leak to the system when the air is lost, which results in the release of all sprinkler heads? Did you get that?
Yes, I got that.
Okay.
Okay, so first of all, not all of the heads are going to release. The leak, the air leak, can occur, and they do occur from number of things, from connections. Imagine how many threaded connections are in a steel piping system, right? So sometimes you will see the compressor that's keeping the air pressure in the system go off every 5 minutes. Sometimes they go off only once a day. So you know there's a leak somewhere. Sometimes they will be addressed, in time. But say there is a power outage, and then the air continues to go out, but the compressor is not working. Yes, there is a low point or a low set point at which the alarm goes off. A low air pressure alarm goes off. It alerts someone in the building or in the monitoring company that there's low pressure in the system. Someone should go and check if it's just a compressor that went offline or something happened, right? But whenever that continues to go on without someone checking, then what's going to happen is the valve is going to open, and then water is going to fill the system. Nothing wrong with that. No head's going to go off because that happens. Then obviously the fire alarm goes off because the water is flowing in the system. The water will stop flowing once the system is full, and then someone has to attend and drain that system. One issue that happens is if that occurs during the winter time and it's very, very cold, and it's not tackled right away, some of the lines may freeze, and then there's no way to address that. Once they thaw, then the pipes break, and once they thaw, then you have a loss. So whenever something like that happens in the winter, you have to make sure, or whoever does the maintenance or the inspection has to make sure that it's addressed properly.
Amazing. Thank you, Eduardo. I'm just going to slip in one last question because I think it's great and it's pretty short. Should a sprinkler system expert be called to advise on a fire loss along with an expert engaged to confirm the cause?
I've been called a number of times to do that, yes. In one particular case that I remember now, it was, and I covered that during my presentation, it was because the fire extended way beyond where it should have. So yes, the system wasn't properly designed or properly maintained.
That's typically something red flagged by the fire investigator, right? So once a forensic expert is retained to conduct their investigation, a part of that is to kind of look at the fire travel and see if there's, like, from a subrogation or even liability standpoint, to pull in a sprinkler system expert or even a fire code expert to comment on whether the suppression systems operated correctly or were installed correctly or designed correctly. Is that right, Eduardo?
That is correct, yes. I would be called after the initial fire investigator goes on scene.
Great. So thank you, guys. We have a stack more questions that we will follow up with you guys by email. We thank you all for your engagement. This is really great discussions. I wish we can go for a lot longer. But thank you again for joining us today. We will be sending completion certificates in the next few days. And thank you so much, Eduardo, for your time and for the presentation.
Mason, thank you everyone for joining today.